So in this video we are going to discuss about stick diagram for combination circuits. So we know that the stick diagram which conveys layer information through color code. It shows all the components and vias. Vias means connection between a metal and a semiconductor. It's called as vias, which is one step closer to layout. So after drawing the stick diagram, we are going for a layout design, and this will helpful for planning the layout and routing. So this 2-input NAND gate we have already discussed. Let us discuss in another circuit. Consider y is equal to a into d plus e plus bc, the whole bar. So you can see b and c is in series. Okay, if it is in multiplication, you have to draw b and c in series. So b and c is in series for NMOS. Similarly, for PMOS you have to draw it in parallel. If it is in series, you have to draw it in parallel. Again, A is in series with D plus E. A is in series with, that is, A is in multiplication with D plus E. So A is in series with D plus E. D plus E is addition. So I have connected in parallel. So this connection should be exactly opposite. You have to draw it for PMOS. So D and E is in parallel, so I have drawn D and E is in series. Similarly, D and D is in series with A, so I have drawn D and E in parallel with A. And you can see the whole block is in parallel with BC, so I have drawn in series with BC. So always the PMOS is connected to supply and NMOS should be connected to ground for this static CMOS logic. Why it is called as static CMOS logic means, since if suppose I consider A and C is in on state. So if A and C is in on state, the output is directly connected to the supply, power supply. So there is a low resistance path occurs between the supply and the output. Similar way, if B and C is turned on means there is a low resistance path exists between the output and the ground. So that is why it is called as a static CMOS logic. Static logic. CMOS means a complementary logic. Okay. So always this NMOS is called as pull down network and PMOS is called as pull up network. So next we have to draw the Euler graph in order to plot the stick diagram. So how to draw the Euler's graph means, for NMOS I have drawn it in green color. For PMOS I have drawn it in blue color. Okay, so let's start from so this vertical portion implies NMOS and the horizontal portion implies PMOS. So it starts from output connected to A and B. So connected to A and B, followed by D and E. D and E is connected to ground. Again it is B followed by C, and the C is connected to ground. Okay, so this is how we have to draw the Euler's graph for NMOS. Similar way you have to draw it for PMOS. PMOS should be in horizontally you have to draw. It should start from VDD to VDD should be in the left hand side and output should be in the right hand side. So let's start from VDD. So VDD, it is connected to A followed by B followed by output. So VDD followed by A followed by B and output. Okay, so next from the output it has to cross the C, then E, then D. C, E and D. then to supply. So I have drawn the Euler's graph. This is how we have to draw the Euler's graph. So from this you have to identify the path. Okay, so how to identify the path means, so let me assume the path called a DA DA, B, C and E. So that is the path D, A, B, C and E. Okay. So similar path I have chosen for, I have to select it for PMOS. So D, A, B, C and E. Okay. So this is a one path. So similar way I can choose E, D, A, B, C. Okay. For PMOS also you should form the that path. Okay, it's E, D, A, B, C. So that's another path. So I can choose D, B, right? I can choose D, B and C, E, A and all. Okay. So if you see, I can choose D, C, B, A, E. You see, D, this is D, I can't go to C, right? You can check D, C, B, A, E. For NMOS it is correct, but for PMOS from D I can't go to C directly, right? So that path you should not select. So this is how we have to select the path. So I have chosen this path EDABC. Okay. So first you have to draw the supply. Okay, this is your supply and this is your ground, and next you have to draw the PMOS. PMOS followed by NMOS. NMOS should be in green color, and you have to draw the polysilicon. Okay, polysilicon should be in the red color, that is EDABC. You have to draw like this. Okay, then you have to choose source and drain. Okay, this is your source and this is your drain, and it can be vice versa. Okay, it can be maybe this is source and this is drain, and or this is drain and this is source. You can choose either way. So for E I have chosen. For PMOS, this point is connected to E and C. So which point is that one? This is that point. Okay, this is a point where E and C is connected. Okay, so what is another point? So this is a if this is source, so the source is connected to E and C. So this is your drain. So this drain is connected to D, right? So this drain is connected to D. Okay, so the source of the D is connected to D and A. Okay, so I have connected between D and A, I have connected the supply. Similar way, the source is connected to E and C. So that is this point E and C. So this is connected to B2. So I have connected to B also, and the output is connected to, output of this one is connected to C, C and output. Okay. So that's all about the PMOS. So here I haven't connected that contact because it is not either connected to the supply or output. So that is why I have removed this one. So similarly for the output, so the output is connected to A and B. So this is your A and this is your B. Okay, so the other end is connected to C. Okay, so the other end of C is connected to the ground. So similar way, you can see the A other end is connected to D and E. So this is D and this is E, and the other end of E is connected, E and D is connected to the ground. Okay, so here you have to write the pulse with this pulse width of the PMOS is the width of the PMOS is always greater than NMOS. So this line represents a demarcation line. There is a rule for demarcation. So you have to study that too. So let us discuss what are the disadvantage of CMOS. CMOS, you know the advantage, it is having very low power dissipation, but the disadvantages, it occupies a very large area compared to the NMOS. Okay, because in CMOS you have NMOS and PMOS, and because of this larger area you have larger capacitance, and this larger capacitance will lead to a longer delay in switching. So that's all about the video. Thank you.